Hello, welcome to this lesson. In this lesson, we talk about integration by partial fraction. So, in integration, there can be some questions whereby the integrand, you cannot integrate it just straight away unless you express it in terms of what? Partial fractions. And in this lesson, we are going to solve those kind of problems. So, we will solve 3 examples in this lesson. So, first of all, we are to evaluate the following. Okay, so let's look at the first question. We are to evaluate the integral of what we have here. So, our integrand is given by this. Okay, so we'll consider this integrand. Okay, and this is what a quotient function, right? A rational function. Yeah. So we express this rational function in terms of what? Partial fraction. So first of all, we need to check the denominator of this rational function, okay? So we factorize this denominator completely. So we choose our function g of x to be our denominator, okay? Now we apply the remainder in the factor theorem, okay? So the factor theorem states that when you have any function f of x such that when you choose any constant a, okay, then if f of a is equal to 0, then x minus a is a factor of f of x, okay? So we are going to apply this basic concept in factorizing our function g of x completely. So we assume a value such that when we substitute it into g of x, we get 0, okay? So first of all, let's choose 1. When we substitute 1 into g of x, you get 0. It means that x minus 1 is what? A factor of g of x. Then we proceed by dividing our g of x by the factor of g of x, which is x minus 1. And you go through this process, okay? X goes into x cubed, that's x squared. Then you multiply x squared by x, giving you x cubed. Then also multiply x squared by minus 1, get negative x squared. When you simplify, you get this, okay? Now, x goes into x squared, just x, we multiply x by x. Then we have what? X squared. We have x squared. Then we also multiply x by negative 1, which is negative x. And when we simplify this, when you simplify it, we get negative 2x plus 2. Now, x goes into negative 2, that's what? Negative 2. Negative 2 times x is negative 2x. The negative 2 times negative 1 is 2. And when you simplify, you get 0. This means that you can express g of x as a product of a linear function and a quadratic function. And our linear function is the what? X minus 1. And our quadratic function is what? X squared. That's our quotient, okay? Our quadratic function, that's what? Our quotient. And this is the quotient, okay? This is the quotient. Okay, so now we have this. Also, we can factorize x squared plus x minus 2 completely using the method of factorization. And when you do that, we are going to get x plus 2, x minus 1. And this is what? The factor of what? F of x, g of x, okay? So this can also be written as this, x minus 1 all squared multiplied by x plus 2, okay? We can now rewrite f of x in this form, okay? And we proceed to express this as a partial fraction. So there is a repeating denominator, okay? This means that this is a partial fraction of third order, type 3, okay? So we can express this in the form a over x minus 1 plus b over x minus 1 all squared plus c over x plus 2. We find the LCM, and the LCM is given by what we have here. Okay, then when we express it, the numerator, we obtain this. You realize that the denominator cancels the denominator, okay, and we are left with only the numerators as indicated in equation 1. Now we are left with what? Finding the values of the unknowns. And how are we going to do that? We use either the cover-up method or the method of expansion, or both. Okay, in this question we are going to use all these two methods. Okay, so first of all, let's use the cover-up method. So for the cover-up method, we find a way to eliminate some of the unknowns, okay, by setting x to a certain constant. Okay, so first of all, we want to eliminate variable a and variable a constant a and what constant c. Okay, so we set x to what? 1, and after setting x to 1, we substitute x into what? Into equation 1, and when we do that, we get this. Okay, so we just replace x by 1. Okay, and the right hand side will be 1 squared minus 7 times 1 plus 9, which gives us 3. 1 minus 1 gives you 0, so this, the first term goes to 0. Okay, then the second term we get 3b, then the third term also goes to 0. We divide through by 3 to obtain b equals to 1. Similarly, we can also set x by what? -2 to eliminate b. Okay, to eliminate b. So first of all, after setting x into x by 2, we substitute it into equation 1. Okay, and when we do that, we are going to get this equation. Okay, and we realize that when you consider the left hand side, we get -2 squared is 4, 7 times -2 is positive 14, so 4 plus 14 is what? 18. Then 18 plus 9 is 27. Now on the right hand side, we have -2 minus 1, which is -3a, but don't forget -2 plus 2 is what? 0, so the whole of first term goes to 0. Now on the second term, -2 plus 2 is what? Also 0. On the third term, we get -2 minus 3 minus 1, which is -3. So -3 all squared gives you what? 9. Then you multiply by c, you get 9c. Then we divide through by 9, which gives us the value of c. Okay, now in order to find the value of a, we need to use the method of expansion. So from equation 1, we expand the right hand side on what? Equation 1. Then we compare the coefficients on the right hand side to the left hand side of the equation, since they are all what? Equal. Okay, so the first term, the expansion gives us this, then the second term and the third term. Okay, now we group like terms. You realize that we have a c, they are like terms because each of them have a variable x squared, so we can group them. Okay, then a, then plus b minus 2c, they are also what? Like terms, since they all have variables x. Then minus 2a plus 2b plus c, they are also like terms because they do not have any variable attached to it, or they are the constant terms. Okay, so since the left hand side is equal to the right hand side, then it means that their coefficients are also equal, and therefore a plus c, which is the coefficient of s squared, is the same as the coefficient of s squared on the left hand side, which is what? 1. So we obtain equation a. The same thing applies to this. Okay, the coefficient of x on the right hand side, since they are equal, then it means that a plus b minus 2c should be equal to what? -7, and the constant term should also be equal to what? 9. We solve equations a, b, and c simultaneously normally, but here in the case we already know the values of b and c, so we don't have to bother ourselves to solve everything again. We can just choose any of the equations Okay, then we substitute our values of b and c to obtain a. Okay, so first of all, you can choose any of the equations. So I selected equation A. You can also choose either equation B or equation C. Okay, so when you select equation A is what? Equation A is what? A plus C equals to 1. Okay, but we know our C. Where is C? We know our C to be what? Positive 3. Okay, so we can substitute our value of C into this. So when you do that, you obtain A plus 3 equals to 1, and A is equal to 1 minus 3, which is negative 2. Okay, so therefore our f of x becomes, here is what? A is what? Negative 2 over x minus 1. Our b is what? 1. Okay, then our c is this. And now we can what? Integrate both sides of the equation. Okay, and when you do that, you obtain this. You see negative 2, 3, they are all what? Scalars, right? And since the integral sign is a linear operator, you can it should satisfy scalar multiplication. Okay, so you obtain this. Now on the first term, you realize that the integral is of the form 1 over x plus 1 is of the form f prime of x divided by f of x dx. Okay, because when you differentiate the denominator, you obtain the numerator. And anytime you are integrating a function of this form, then you always obtain what? A lane function. Okay, you will always obtain a lane function. So this means that the integral on the first term will be negative 2 ln x minus 1. Okay, now we have the second term. The third term, we realize that the derivative of x plus 2 with respect to x is 1, and that's what we have on the numerator. And that's also going to be what? A lane function, and that will be lane of x plus 2 plus arbitrary constant. Now we are here to integrate the second term or the middle term. So we can integrate the middle term by substitution. Okay, so we let our denominator, we let x minus 1 be u. This implies that du dx, the derivative of u with respect to x, is just 1, and we can rewrite this as what? Du equals to dx. Okay, so therefore our integration or our integral becomes 1 over u squared du, and this gives us the integral gives us what? Negative 1 on u, but we know our u to be x minus 1, so we can substitute and obtain this. And therefore our final result is given by negative 2 ln x minus 1 minus 1 over x minus 1 plus 3 ln x plus 2 plus c. Okay, and we can say we have like terms. Some of the terms are what? Lane functions, so we can just group like terms and simplify. Okay, now per the rules of log, this lane function can be written as what? This, and thus when you have a ln f of x, then you can rewrite is the same as the lane of f of x or exponent a. Okay, so our a is what? The 3 here, so you can rewrite this as this. The same thing applies to the first term. Okay, then we obtain this. And also one of the rules of log states that when you have the natural log of f of x minus the natural log of g of x, then we can rewrite this as the lane of f of x divided by g of x. Okay, yes, so but since you see this is of to the power 3 and this also to the power 2, so we write it in this form. Okay, we are dividing because of this minus sign here. Okay, so this is what our final answer. Now let's look at the next example. Okay, we also have another nice question here. Okay, we have another nice question here. we let our integrand be what? F of x, okay? And we realize that the degree of the numerator of the rational function is what? Is 3. Okay, that's highest index. So we have the degree is 3, and when you consider the denominator, the degree is what? 2. Okay, this means that our rational function is what? Improper. And anytime you are expressing any improper rational function in terms of partial fractions, then you have to express it in this form. That's quotient plus remainder over the divisor. Okay, quotient plus remainder over the divisor. So first of all, our divisor is the denominator. Okay, so we divide the numerator by the denominator. Okay, so we have x squared minus 9 dividing the numerator, which is x cubed plus 2x minus 10x minus 9. Okay, so let's begin. So x squared goes into x cubed, just x. Okay, then we multiply x by x squared, we obtain what? X cubed. We also multiply x by negative 9, we obtain negative 9x. Okay, and because of this the second term 2x squared, that's why we decided to bring the 0x squared, so that's it will be very simple for us to simplify. Okay, so now we have minus 9 here, then minus 10x minus negative 9x is minus 10x plus 9x, which is negative x. Then 2x squared minus 0x squared is 2x squared. Now x cubed minus x cubed gives you what? 0. We also divide 2x squared by x squared, okay? And 2x squared divided by x squared is just 2. Then we multiply 2 by x squared, we obtain 2x squared. Then 2 times negative 9, that's what? Negative 18, okay? Okay, so okay, so you obtain this. Okay, so now let's simplify. Negative 9 minus negative 18 is just negative 9 plus 18, which is 9. The negative x minus 0x is just negative x. Then 2x squared minus 2x squared gives you 0x squared. So now our remainder is what? Negative x plus 9. Our quotient is x plus 2. So this is our remainder. And x plus 2 is our quotient. And this is our divisor. Okay, so we have our quotient, we have our remainder, then we have our divisor. Okay, so we can rewrite f of x in the form quotient. Our quotient is what? X plus 2 plus the remainder, which is negative x plus 9 over the divisor. Okay, and we can also rewrite this as that because negative x plus 9 is the same as 9 minus x. Okay, now let's consider the second term. It's easy to integrate x plus 2, right? But on the second term, we will need to express it as what? A partial fraction, okay? So now let's express the second term by partial fraction. You realize that x squared minus 9 is just a difference of 2 squares, and it's x plus 3, x minus 3, okay? And this typical type 1 question, okay, in partial fraction. So because the denominator is just a product of two linear functions, okay? So we can rewrite this as a over x plus 3 plus b over x minus 3. And when we simplify this, you see x squared minus 9 cancels x squared minus 9, okay? So we obtain this, okay, because on this step, you see x squared minus plus 3 cancels this, and it will be left with what? X minus 3. Then you multiply by the numerator, we obtain this. The same thing applies to the second term. Okay, so here we can straight away use the cover up method. So first of all, we use cover up method to eliminate a, okay, by setting x equals to 3. So now let's substitute x equals to 3. So maybe we can name this as what, as your equation 1. Okay, okay, so when you set x is equal to 3 and substitute it into equation 1, it will be 9 minus 3 equals to a times 3 minus 3 plus b times 3 plus 3. But 9 minus 3 is 6. 3 minus 3 is 0. 0 times a is what? 0. Then 3 plus 3 is 6. So we obtain 6b, and this implies that when you divide through by 6, you get what? 1. Again, we can also set x into by what? Negative 3 and substitute it into equation 1. And when we do that, we will obtain this, okay? And when we simplify, we obtain negative 2 to be what? A. And therefore, our f of x, okay, our f of x is now this, and we can easily integrate this, okay? So we have this integral, okay? So the integral of x is what? X, this is x to the power 1, so we add 1, then we divide by 2, okay? That's 1 plus 1. So we obtain x squared divided by 2. Then the next term, you see we have negative 2 over x plus 3. And we can rewrite this integral as negative 2 integral of 1 over x plus 3 dx, right? But the denominator, when you differentiate the denominator, you get what? 1, and that's what we have as the numerator. So you obtain the length function, okay? So that will be negative 2 times the length of x plus 3, that's the natural log. The same thing applies to the third term, okay? So when you differentiate the denominator, you get 1, and 1 is what? The numerator, and it will also be what? A length function plus an arbitrary constant c. And we apply the rules of log, okay? And when we do that, we see we have the first term to be x squared plus 2 plus 2x, okay? And this is just like, we can rewrite these two terms as the length of x minus 3 minus length of x plus 3 all squared, okay? And this is just like length of x minus 3 divided by x plus 3 all squared, and that's what we have here, plus an arbitrary constant. Now, before we solve the last example, you can pause this video and try your hand on the question. Let's go back to the question. Let's go back to the question. Question 3. I would advise you to pause this video and try your hand on the question before you come back to the solution, okay? So we have the question here. Okay? You have a very nice question here. So you can try this particular question. Okay, now this is the solution. Maybe you can compare your answer with mine. Okay, so we let our integrand be f of x, okay, and we express the integrand as a partial fraction. This is a partial fraction of the second type because the denominator, this is just a product of a linear function and a quadratic function. Okay, the quadratic function is just the 1 plus x squared is quadratic, okay, and the linear function is 2x plus 1. And when you're expressing in a partial fraction, it should be of this form, okay? Yeah, so first of all, we find the LCM. When we find the LCM and simplify, we get this. Then the denominator cancels out, okay? So we use method of expansion to find the values of A, B, and C. Okay, so the right hand side, we have the right hand side, we have the left hand side, A times this, and when you multiply bx plus c by 2x plus 1, that will be bx multiplying 2x plus 1 plus c multiplying 2x plus 1, and this is b 2bx squared plus bx plus 2cx plus c. Okay, and that's what we have here. Okay, so now we can now group like terms. We realize that a 2b and 2b are like terms, right? Because they all have a variable x squared. Okay, so we group them. Also, b and 2c, they are also like terms because they all have variable x. Okay, then a times 1, that's a, then c, that's a plus b, because they are constant terms. Okay, so we also group them. So now we compare the right hand side or the left hand side. Since they are equal, it means the coefficients are also equal. So a plus 2b is just like 3. Okay, so we have equation 1. So b plus 2c is equal to 2 as equation 2. Then a plus c, that's a constant term, that's equal to 4 as equation 3. You can now, there are two ways of solving this problem. You can solve these equations simultaneously. That's by using elimination or substitution. Okay, or you can also use the Cramer's rule. Okay, and that's my favorite. Yeah. So I solved this problem, okay, using the Cramer's rule. So for the Cramer's rule, you express the simultaneous equation in this form, okay, where z is our coefficient matrix, our x is the unknown, and b is what the right hand side. Okay, so the coefficient matrix, you see, when you consider equation 1, we have these are 3 variables and 3 equations, so we are going to obtain a 3 by 3 coefficient matrix. Okay, so that will be, when you consider equation 1, the coefficient of A is 1, coefficient of B is 2, and there is no C. It means that the coefficient is 0. Also, when you consider equation 2, there is no A. It means coefficient, so you can rewrite this as 0A. Okay, 0A, and this term 2 plus 0C. Okay, okay. So we have 0 plus 1. Okay, so we have 0, 1. Then the coefficient of C in equation 2 is 2. Okay, in equation 3, we have A, that's coefficient is 1. There is no term containing B, so we can write it as 0B. Okay, so that's why we have 0 here. Then C, that's coefficient is 1. And our variables, we have A, B, C. That's what we are looking for. And our right hand side, we have 3, 2, 4. That's what we have here. So now, for the Cramer's rule, when you are solving for each of the variables, first of all, let's solve for A. Okay, so you consider the coefficient matrix. Okay, you find the determinant. But this time around, you realize that when you are finding for A, all these column elements, they are the coefficient of A. And therefore you have to replace all the coefficient of A by the constant terms. That's the element of B. Okay, so you replace all the coefficient of A by what? The right hand side. Okay, then we maintain the second and the last 2 columns. Okay, then we divide by the determinant of the coefficient matrix. Okay, so now the determinant of the numerator is 15, the determinant of the denominator is 5, and we obtain 3. Okay, now when you are also solving for B, we replace on the numerator, we replace all the columns and all the coefficient of b by the element on the constant term, okay, elements of matrix B, okay, or vector B. A vector is also a matrix, right? So we maintain element in the first column, we just maintain it in the last column, but element in the second column, we replace them by the constant terms or the right hand side values, okay, since we are looking for B. But the denominator, okay, the denominator always remains the same. That's the determinant of the coefficient matrix. But this matrix, the determinant, when you find the determinant, that to be 1 times, so you delete this row, you delete this column. 2 times 1 is what? 2 minus 8 minus 3. We delete this row, we delete this column. 1 times 0, which is 0 minus 2, okay, plus 0, okay. So we have minus 6, minus 6, okay, then minus 3 minus 2, 0 minus 2 is negative 2, so negative, that's positive, and minus 3 times minus 2 is just positive 6, okay. So we obtain 0. This means that the matrix, the numerator is a singular matrix, or it's a non-invertible matrix, okay. You can read more on matrices, okay. So we obtain 0 over 5, which is 0. Then for C, you replace all the columns, okay, all the coefficient of C by the constant terms, okay. So you just maintain the first two, then you replace 0 to 1, which is the coefficient of C, by what? 3 to 4, okay. Then you find the determinant, you divide by the determinant of the coefficient matrix, and we do that, you get 5, you get 1, sorry. So therefore our f of x, you realize that if you could remember, our f of x should be of the form a over 2x plus 1 plus bx plus c over 1 plus x squared, right? As indicated here. Let's refer. Okay, yeah, we have it here. Yes, we have it here, okay. So okay, so good. We have, when we solved for a, where is a, we had, okay, we had a to be what? Positive 3, we had b to be 0, and c to be 1, okay. So we substitute here, we substitute it here, okay. So we have a 3 over 2x plus 1, then b is what? 0, so 0 times x is what? 0, plus c, which is 1, so 0x plus 1 is just 1 divided by 1 plus x squared, okay. And we obtain this, and separately we can solve the first term using method of substitution. So we let our u to be our denominator, that's 2x minus 1. So this implies that the u, the derivative of u with respect to x, is what? 2, and this is the same as 2 dx equals to du, okay. And our equation, our integral becomes 3 times the integral of u, then the s is what? Du on 2, and we can rewrite this as 3 over 2 integral of 1 over u du, okay. But you see that the derivative of u with respect to u is 1, and that's what we have in the numerator. So we obtain a length function, you multiply it by 3 over 2, okay. But our u is what? 2x plus 1, so you substitute it here, and therefore our final answer is 3 on 2 ln 2x plus 1. Then the second term, the integral of 1 over 1 plus x squared dx is the arctan of x, okay. arctan of x. You can verify this by differentiating arctan of x, okay? When you differentiate arctan of x with respect to x, you will get 1 over 1 plus x squared, okay? So you obtain arctan of x plus an arbitrary constant. Thank you.